Hello, Algebra 1B. I'm going to be looking at the notes on system, word problems, and graphing. I love this this lesson because it's putting together all the stuff you guys learned about, like writing equations from word problems back in Algebra 1A and pre-algebra. It's putting all of that with what you've been looking at with solving systems by graphing. So it's using what you know about graphing and what you know about word problems all together. So it should be a good review lesson of that stuff. I'm going to look at the very first example in the notes, this one here. So it starts off by asking you to represent a word problem with an equation, which you guys already know how to do. It's got today the average temperature in New York is -1 degrees, and it's expected to rise 3 degrees per day. And the first part just asks you to write an equation to represent that. So if you have not already gone through the notes, if you want to pause this video, try to write an equation from that. Again, that is my shorthand way of writing. It's starting off at -1 degrees and it's going up 3 degrees each day. So you want to pause the video, try writing an equation. All right. So our equation could look something like this. We could say, well, it's starting at -1, and it's going up 3 degrees each day. Going up means we want to add 3 degrees times however many days have passed. So I'll use D. Maybe off to the side, I'll write D represents the number of days that have gone by. And then it needs to be an equation. So I could say that equals, let's call it T, where T just represents the temperature in, we were talking about New York. So that's our first equation. Not too bad. We've got a second word problem they've given us. The second one says it's 6 degrees in Alaska and expected to fall 1 degree every 2 days. So now we are talking about Alaska, and it's telling us Alaska is starting off at 6 degrees and it is falling. It's telling us 1 degree every 2 days. Again, I'm going to say if you have not already looked at the notes, go ahead and pause the video now and try writing an equation from that. I was trying to pause my video. Okay. I think this one's a little trickier, and we'll see in a second why. Similar to this first one, we could say our equation starts, we're starting at 6. The temperature is falling, so it would be minus 1 degree every 2 days. Now, thinking back to what we had written here, this says 3 degrees each day. When we're writing that equation, we need to know what the temperature changes for one day, for each day. They didn't give me this, so I can't say minus 1D or minus 2D, because minus 1D means it's falling 1 degree each day. Minus 2D means it's falling 2 degrees each day. And that's not what it's saying. It's saying it's falling 1 degree every 2 days. How much is that temperature falling every 1 day then? Means it's falling half a degree every day. If it takes 2 days to go down 1 degree, so day 0, it's at 6. Day 2, it's fallen 1 degree, so it's gotten down to 5. That means after 1 day, it's only gone down half a degree. I say all that to say, starting at 6 degrees and it's dropping half a degree every day, and we could say that equals our temperature. So again, we've got D is the number of days that have passed, and now T is going to be our temperature in Alaska. This part here can be a little tricky, but other than the half a degree every day, I've given you problems similar to this, where it's the word problem we're writing an equation. The new part's going to be what comes next. In part C, they ask us to graph both equations below. So this is the point in the lesson where I wish I had graph paper, but I don't. I'm gonna give myself some room real quick. And I'm gonna put that Alaska equation up above it. So 6 minus d equals t. So you may have graph paper because you may have the notes printed, or you may be like me. I'm just gonna draw our coordinate plane here. So it's asking us to graph these two lines. When I go to graph, well, your first one would be this one here, which is New York. We would start this graph at -1. So you would be putting a point down here at -1, and then it's going up 3 degrees each day. So we would go up 1, 2, 3, over 1 and put a point. Go up 1, 2, 3, and over 2 and put another point. And we'd get a line going through those points. You may have room for more points. Just like a quick check of what this is saying. This x-axis is talking about what? Well, in our equation, d is where our x would normally be. That x-axis is talking about your days. Our y-axis is talking about what? Well, instead of equal to y, it's equal to t. But that y-axis is talking about temperature. So what this is saying is at day 0, it starts at -1 degrees. By day 1, it's gone up 3 degrees after 1 day. So day 1, it's 2 degrees. By day 2, it's up, what is that? 1, 2, 3, 4, 5. So it's gone up another 3. The line's going to match with what the equation's saying. Now, when you go to draw your line, you could just go ahead and draw a line through these points. In the past, when we've graphed some lines, we've seen with some word problems, we don't end up going backwards. In this problem, we have to think, what would it mean if I drew a line over here? Well, if I ended up going ahead and putting like a point down here, that would mean at -1 days, the temperature is down here. I'm not going to even figure out what number would be down there because I just said -1 days. We can't have negative days. So this is going to be another one of those graphs where we don't need to come over here into that left side of the graph because over here are negative numbers. If you want to on your graph, you can even write a note to yourself saying that there is no line on this side because, you could say because there are no negative days. You could say because we want to start at day 0 and not go back into the negatives. Lots of different ways you can think of it. But we've got this black line right here represents the temperature in New York. I'm going to go ahead and graph our second line as well. Our second line is Alaska. And we'll graph Alaska the same way. If you want to go ahead and try graphing it on your own, pause the video now. I never know what to do after I ask you to pause the video, except just pause. But maybe you've graphed now. If we want to graph this one, we're going to start at our y-intercept, which is 6. 1, 2, 3, 4. What did I do? 1, 2, 3, 4, 5, 6. So day 0, our temperature is starting at an average of 6 degrees, and then it's dropping half a degree each day. Now we've seen before when we were graphing, this right here represents your slope. It represents your rise over run. So a quick reminder, if your slope is 1/2, that means rise 1, run 2. Our slope is -1/2, so that means when I go to do my rise, I want to go down 1 and over 2. So when I go to graph my line, my next point I can find by going down 1 and then over 2. Oh, look, it happens to be right here. We could keep going if we wanted with that, but I've got enough points to see where my line is. I want to kind of like quickly pause and check to see like what is this line actually saying. We've said on day 0, it's starting at 6 degrees. And then what is it doing? It is going down 1. The temperature is going down 1 after 2 days. Well, that's what the word problem originally said. Remember how we said it's expected to fall 1 degree every 2 days? That's what this slope is saying. It's falling 1 degree, temperature's going down 1, after 2 days. Ah, look, slope. I could finish my graph by labeling this line too. I'm going to go ahead and label it Alaska. So notice, because it's a word problem, we're graphing again. I'm labeling everything. I've got my x-axis is days, I've got my y-axis is temperature, and the new thing now is because we're talking about 2 lines, we want to label which each line is. I've got the benefit of colors, so mine are different colors. Can you even tell they're different colors? Maybe not. But you can do it however you would like. The punchline to this problem is connecting it back to what we've been learning recently about systems of equations. So when you were in this previous lesson graphing to solve systems of equations, where were we looking on the graph? Hopefully you're looking at this point right here, that intersection point. Now before, we were just calling that intersection point the solution point, but the solution point didn't have much meaning other than the fact that it was that one point on both lines and that one point that satisfies the equations. All of that is still true, but we've got much more going on now because we're talking about temperature and days and Alaska and New York and all this extra stuff. Think about this point for a moment and what this point is telling you in the context of temperature, days, Alaska, New York, all of that. What does this point here mean? Well, this point right here, what is that point saying? It's saying on day 2, the temperature was 5 degrees. On day 2, the temperature was 5 degrees where? Well, the temperature was 5 degrees in both Alaska and New York. So that point there, that magical point, that is where those 2 cities, or sorry, I guess we're talking about states, New York State and Alaska State. It's where those 2 states are the same temperature. It's the same day, same temperature. Every other point we were plotting, they're a different temperature. So on day 1, we've got New York was down here, Alaska was up here. By this was day 4. Day 4, Alaska's down here, New York would have been somewhere up here. Every other day, they have different average temperatures, except for this one magical day here, where it was the same. So that solution point that we were talking about in the previous lesson, it has a lot more meaning when you give it a context. So the last question for that example says, describe what you learned from the graph. We can kind of summarize everything we were saying here. If you want to take a moment, try to summarize it on your own. So probably what I would say about this one point here, we could say on day 2, the temperature, I'm going to write short so I don't run out of room. The temperature in Alaska and New York was the same. You could even tell me 5 degrees. If you wanted to go further, if you just want me to go, oh, wow, they really get it when I'm reading your answer on the computer, home alone. You could also go a step further by comparing the temperature outside that point. So thinking about before day 2, what could you say about these 2 temperatures? Well, when you're comparing temperatures, what are some of the words you usually use? You could use like hotter or colder. So we could say before day 2, the temperature in New York compared to Alaska, what could you say about New York? The temperature here is lower. It means it was colder. So we could say before day 2, the temperature in New York was colder. Or you could say that before day 2, the temperature in Alaska was warmer. Use warmer loosely because it's 5 degrees. And then after day 2, what could we say about after day 2? Well, we could say Alaska was colder. Or you could say New York was warmer. That just takes it a step even further. So that way you're describing the entire graph now and not just this one point. like we saw in the previous set of notes, it's that solution point is usually where all the focus is, but we have all this beautiful graph. You can learn so much more about it. So that would just take it a step further. I don't really have much room to write that down here, but what you could say is something like before day 2, the temperature in New York was colder. After day 2, the temperature in Alaska was colder. Something like that. It's the point where they flip. That is all I have for you for this example. On the back side, there are, oh, look at that fun. There are 2 for you to try on your own. For some of these ones in the notes that you're trying on your own, but you're not sure if you got correct or not, once again, this is my reminder. I miss all of you so much, so feel free to call me or email me or send me a message on Remind if you've done some extra stuff that you want us to check. The Google form is what we're doing for the homework so that you can at least get feedback that way. I know not everyone has the technology to like scan homework in. You can always take pictures if you've done something else and send them to me that way. Might not be the easiest way which is why we're using the Google form. But that said, like if you do end up trying some of these ones on the back, especially these ones with the graphs, and you want me to check them or Denise to check them, please feel free to reach out. Don't forget about the tutoring. And of course, I would love to hear your voices too. With that, I wish you the best of luck with this. Hopefully you love this lesson as much as I do. And I know, again, it's new, but you guys you've been doing really well on the stuff you submitted. So I miss you all, but keep being awesome. Thanks. Bye.